Alright, let's investigate further some different horizontal shifts and see what's going on here. First of all, let's look at f of x equals x minus 2. We're going to start at x and then we're going to subtract 2 from it. You might find a surprising result. So here's f of x equals x in the green. The parent function is y equals x, or p of x equals x. Let's go ahead and subtract 2 from x and see what happens to our graph. Now here's what's wild. If we subtract 2 from x, it actually shifts 2 units to the right. In other words, the parent function shifts 2 to the right to end up with the transformed f of x function, even though we subtracted 2 from x. Why is that? Let's look at another one. Let's look at f of x equals x squared. We're going to subtract 2 from x and then square that quantity. And then again, we can see that the transformed function shifted 2 units to the right from the parent function even though we subtracted 2 from x. I want to figure out why that is. Okay, well, for our next example, we're going to do square root of x. We're going to subtract 2 from x and take the square root of that quantity. And again, we can see that it shifts 2 units to the right even though we subtracted 2 from x. In other words, the parent jumped 2 to the right to end up to the transformed function. I want to show you some reasons for why that is. We can see that when c is negative 2, the parent graph shifts 2 units to the right. But why? Well, let's go back to our x squared function. We know that p of 0 is equal to 0. What exactly is a horizontal shift? Let's go back to our x squared function. Horizontal shift means that the same y values, you will have the same y value but with a different x value. So notice our first y value was 0. First x value was 0, that gave us the y value 0. The second x value was 2, that gave us 0. So we want to keep the same y value for horizontal shift. So if we want to show that algebraically, the parent function, the original vertex, was at x equals 0. For our new transform function, since it's x minus 2, we're going to have to plug in the opposite of negative 2, positive 2, to end up with the same y value of 0. Therefore, we've moved from an x value of 0 to an x value of positive 2, and that's why the horizontal shift is positive 2, given that it was x minus 2. But let's look at a different point. Let's look, for example, at p of 3. Let's go back to the graph. Notice that p of 3, we get 9. For our parent function. Notice that for our transform function, you have to plug in 5. So you still have to plug in 2 more, even though it's x minus 2. Now we're starting to see why that is. We would have to plug in 3 plus 2 in for x in order for the minus 2 to cancel to ensure that we still get 9 back. See, the positive 2 and the minus 2 cancels, and we end up with 3 squared, which is 9. In other words, we want to plug in the same number that we originally plugged into our parent function. In order to do that, we have to cancel out the minus 2. In order to do that, we have to add 2 to our original x value. This, in essence, is why the horizontal shift is going to be 2. In other words, we're adding 2 to the 3 to get 5, and if we plug in 5 in here, we get 5 minus 2, which is 3. 3 squared is 9. It gives us the exact same y value. We get 5 comma 9, which is the same as 3 comma 9. Another way to show this is algebraically. So suppose that we didn't know to plug in 5 here. Well, the way to figure it out is if we want the same x value, if we know that if we plug in the same x value here, we're going to get 9, then why not just set this equal to 3? We know if we plug in 3, we get 9, right? 3 squared. So why not set 3 equal to x minus 2? And that's what we're going to do. So if we set 3 equal to x minus 2 and we add 2 to both sides, we can visually, algebraically see that we must add 2 to the 3 in order to ensure that we get 9 back. In other words, 3 plus 2 is your horizontal shift. And if we do 3 plus 2, we get 5. And therefore, we know that if we plug in 5, that's just 3 plus 2. It's the plus 2 and the minus 2 is going to cancel, and it gives a 3 squared, which is 9, which is the same y value that we started with. In other words, 5 is 2 more than 3, and we've shown that algebraically by setting 3 equal to x minus 2. And so you can see that it has to do actually with the property in math, the addition property of equality. It'll cancel out that minus 2. that's going to be it for this short introduction to why when we have an x minus 2 inside of a function that the horizontal shift is actually going to end up being plus 2, because it's the reverse algebra to solve for this x value. If you have any other questions about this video, let me know.